Howdy howdy guys! So for this video we are going to learn how to find the K sub A from a given pH for a weak acid, right? This is all for a weak acid. So HZ, we'll call it, is a weak acid. This is from the homework. Is a weak acid. The pH of a solution of 0.020 moles of HZ, sorry, notation changed, in water is 4.93. So what is the K sub A of acid HZ? So first off, we can write the equilibrium expression. Sometimes I find that helps me and other people. Right, this is the equilibrium expression. And what they're saying is that we have a concentration of 0.020 moles in 1 liter, so we can actually make an ice table. It's not exactly necessary to solve this, but sometimes it helps people who are more visual. So that many moles in 1 liter is just that many molarity, so 0.020. And initially we're going to assume we have 0 and 0, right? So then do we know any of these final concentrations? We know that the change is going to be minus x for this, and it's only 1x because there's a coefficient of 1 here. And it's going to be plus x and plus x. So we know that it's going to be 0.020 minus x, x, and x, right? So, however, do we actually know the pH of the solution? So what do we actually know? We know the concentration of H plus at equilibrium, don't we? So since pH equals negative log of the concentration of H plus, we know that 4.93 equals negative log of the concentration of H plus. Therefore, negative 4.93 equals log of H plus. Therefore, so we take I guess some people call it the antilog of negative 4.93, but it's 10 to the power of negative 4.93. And we get 4 zeros and a 117. Equals x. So we know this, right? We also know this. 0.020 minus this number, this is actually negligible. If we were to type in our calculator 0.020 minus that small number, we still essentially get 0.020, right? So let's write our K sub A expression. Right side over the left side, products over reactants. So it's going to be x times x over 0.020. This is negligible. And in a lot of problems that I give you, I'm going to tell you whether or not plus x or minus x are negligible. There should only be one where you have to use the quadratic. So we know what x is now, so we can plug that in here. So it's point, and looks like there are 4 zeros and a 117 squared over 0.020. So if I tippy type this into my calculator, okay, and then I divide by 0.020, I get 1, 2, 3, 4, 5, 6, 7, 8, 9. I get 7 times 10 to the negative 9 is my K sub A. Yes. Yeah, my calculator doesn't have that many digits on it. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, 7 times 10 to the negative 9. This may be like 7.1 or 7.2, but my calculator doesn't go that far out, apparently. So that's how you go from pH to K sub A. So to wrap it back up, to find the K sub A of a weak acid from the pH at equilibrium, you're given a weak acid and you will be given maybe the pH of the solution and you're given a concentration. Then we can set up our ice table. But since we know the pH at equilibrium, we know how to find the concentration of H+, and that just so happens to be the number x. So then we can plug in x. So we actually know that this is equal to 1.17 times 10 to the negative 5, right? We know this is equal to 1.17 times 10 to the negative 5, right? And then we know that this is essentially going to just be 0.020 because this number is negligible. So then we went and set up our case of A equation, and then we just plugged in our numbers, and my calculator cut it off at this many digits, so it won't go past 10 digits. So 7 times 10 to the negative 9 is our case of A, and that is how you go from case of, how you find case of A from a given pH and concentration. Thanks!